those of you that do not know, the carbon footprint of a 6-ounce coffee, like a flat white or something, is around about 250 grams. And this is the exact same slide I showed 3 years ago. And truth be told, when I showed it 3 years ago, I was about 75% sure that it was right. But I was like, it's close enough, let's go for it. And over the last 3 years, there's been a bunch of work that's been done across industry and in academia, and these numbers are getting more and more sure. And so the interesting thing is that around about 3/4 of the entire carbon footprint of a cup of coffee is from the milk. Around about 22% is from the coffee origin, from the supply chain, and most importantly, from the making of that coffee. And then around about 5% is from the takeout cup and the lid. And my point 3 years ago, and it still stands, is that this is a very, very difficult thing to change. There's a bunch of things that we can do here, and there's a bunch of things that we can do here. This is also a slide that I showed 3 years ago. It is 4 different academic studies that look at the carbon footprint across the supply chain for a cup of coffee through different methods. So like, this is kind of like more like a specialty coffee shop, but in North America, I forget what this is. This is like capsules or something. This is like at home, and I forget what this one is. And the point of the slide, though, is not to get hung up on the specifics, but is to point out that in most coffee methods, the amount of the coffee's carbon footprint from the origin is very, very small, maybe like 1/4. Most of it is this big red box, which is the coffee making component, and most of that is from electricity. So this is a new slide, and you can also get a copy of this on United Baristas. An espresso machine, if you do some maths, uses something in the order of around about 15,000 kilowatt hours of electricity per year. And we've got sort of like a confidence interval here. But the interesting thing is that that's around about 3 or 4 times the amount of electricity that an average UK home uses. Espresso machines are just incredibly inefficient. So what we're doing is we've got this milk bit, and we're now just focusing in on this bit here. If you take that 15,000 kilowatt hours, and actually most of you will be quite aware of the cost of electricity, so that 15,000 kilowatt hours is now going to cost you maybe like £12,000 a year to run. We're talking an incredible sum of money. If you use the average conversion ratios for electricity generated in the UK, that 15,000 kilowatt hours produces a carbon footprint of about 4.5 tons, and that's quite a lot more than a return flight to Costa Rica to go sourcing. And if you multiply that and do some maths and work out what that would mean per cup, the electricity used to make an espresso contributes around about 3 times the carbon footprint of the cup, takeout cup in which it's served. And so what I'm trying to do is build a picture here that in a cup of coffee, there's a bunch of things that really matter, and there's a bunch of things that don't really matter. And the things that matter are the milk and basically the electricity that's used to make the cup of coffee. And we pointed out there must be some really good results coming in up the top, right? So we're going to have a bit of a chat about milk and some other things, and then what you can do if you want to reduce the amount of electricity in a cup of coffee is that you can go use a more efficient espresso machine. And you can go up to, like, the most energy efficient espresso machine probably on the market at the moment is a machine called the Eagle One. And you can go up and see Camilla or someone up at Victoria Reno, and that uses around about 1/3 less electricity than others. Hi, my name's Tim from United Baristas. So, now that I've successfully brought you up to speed, I would now like to move from a cup of coffee to an entire coffee shop. And we've kind of defined this in a very specific way, because we're not talking about the construction of the coffee shop, we're talking about the operations through the coffee shop. So, just need to check what slides I've actually done here. Okay, I need to tell you the methodology. So what we did is we went to a proprietor who's got several shops here in London, and I shouldn't point out, this isn't just me. I'm involved in a project, and I'll tell you a little bit more about that later. But we went to a proprietor, and we got 2 years worth of invoices, and we went and worked out how much milk were they using, and what were their electricity bills, and how much electricity did they use, and how many pastries did they actually buy, not how many did they sell. And then we took all of that, and we collated all that information, and then we ran it through some databases, and that spits out the average carbon footprints for those types of items, so we could start to work out in very broad brushstrokes what is the carbon footprint of a coffee shop. And this is the result. So the thing that you might notice by far and away, that this big bar up here is milk. This one here is this shop's entire food carbon footprint. This is a shop that has this is a shop that's serving hundreds of cups of coffee a day. They have a food menu that's quite narrow. It's counter-only food. And they are mainly doing like around about 15% of their sales revenue is from food. This is their carbon footprint from their coffee beans. And remember, that includes the growing, the export, the import, the roasting, and the packaging. Next to nothing. Good job. This is the electricity for the entire shop, and quite a lot of that is the electricity for the espresso machine. This is an estimation for what the packaging footprint is for like cups and takeout bits and pieces. This is their leftover waste, and then if we were able to get that waste into different systems so we could get some energy back from it, that's some kind of potential benefit. And I think the thing that absolutely blew my mind when we got this data back is I was like, oh my goodness, look, much of this shop's carbon footprint is milk. Isn't that amazing? And also I was like, oh my goodness, this is a problem that I already know the answer to. So what have I done next? We're just focusing on this pink bar now, this milk bar, right? And this is the same pink bar here, because this shop uses dairy milk for around about 80% of its sales, and then uses an oat milk for around about 15% of its sales. So we took the actual carbon footprints for those particular milks to calculate this bar. And so if this shop entirely sold dairy milk, it would be this blue bar here. And if it went, so I should point out that in Europe, a 1 litre of dairy milk has a carbon footprint of around about 1.6 kilograms of CO2 per litre. Did I get that right? Yeah, I got that right. An average oat milk has a carbon footprint of around about 1 kilogram of CO2 per litre. And then the current leader of the pack, Oatly, has an average CO2 of around about 0.44. But actually, I got a packet the other day, and I think it's gone to 0.49, something like that. So basically, you can go from, if you go from all dairy to oat milk, you almost go half, but not quite. And if you go from an average dairy milk to Oatly, like front of the pack for carbon footprint, you halve your carbon footprint again. So once you remember these 4 bars, because what I've done here is we've put, this is the actual, and then that was if it was all dairy, if it was all oat, and then it was all Oatly. And if you take the difference between this all Oatly bar and you take this actual bar and you translate that, it's actually, that would be a 10-ton of carbon footprint saving in this particular shop, which is like an extraordinary amount of CO2. And in fact, significantly more than their entire carbon footprint from their food menu. So I think one of the things that's been absolutely amazing as we've worked through this process in this first phase of the study is that within all the things that go on in a coffee shop, whether it's the electricity or the coming and goings or the deliveries, the key causes of the carbon footprint that we need to be able to tackle in is 1, what milks we use, and 2, the amount of electricity that espresso machines use, which is basically exactly the same findings that I stood on the stage 3 years ago when we were talking about a cup of coffee and said, these are the things that really matter. So one of the things that's going to be really exciting is that in 2023, there's going to be a project where lots of different coffee shops are going to have the opportunity to be able to come together and provide their data so they can actually build a bigger data set about what's happening across the coffee industry outside of these 2 pilots. And we're going to have some more accurate reference points for you so that you'll be able to plug in some data for what your specific coffee shop is so you can start to look at the entire carbon footprint of it. There's lots more resources about coffee's carbon footprint on United Baristas. I'm going to be around. If you've got any questions, come and have a chat to me. But I hope this encourages you where you can put your efforts to make a difference. Because I guess the fundamental thing is that time is really precious. We've got limited time. We've got limited resources. So let's just do the things that count. and not worry about the other stuff. And focusing on those things would really make a difference. Oh, and if you want more information like this, you can get your phone out and you can scan this QR code and you'll be able to go to this website. And then if you do that, you put your details in, then every month you'll get an email that tells you how to be able to reduce your coffee's carbon footprint. Amazing. Thanks very much, guys. It's been great.